So, welcome all to Dr. MDS Academy. Here I am going to present animations which shows that how the 4 bar chain actually moves. So, in lecture we had seen that types of kinematic chains were 4 bar chain, second was single slider crank chain, and third was double crank chain. So, in this animation I am going to demonstrate only the first one, that is the 4 bar crank chain. Inversion of 4 bar chain are we are having three examples for. One is the beam engine, okay, also known as a crank and lever mechanism. Second is the coupling rod, also known as double crank mechanism because we are having a double crank, link and four and two. Okay, and the third and the last one in inversion of 4 bar chain example is Watt's indicator, also known as a double lever mechanism because we are having two lever. Okay, in this case. So let's see in the animation here. In the animations, okay, the first one is the beam engine crank chain. Okay, the first one. Okay, the red one line is showing that the how the trace or the construction of the lines this mechanism is making. Okay, the second one is the coupling rod. Okay, also known as a double crank. Okay, see the red circle is showing that how the construction line is developed by this 4 bar chain. Okay, and the third one, last one is the Watt's indicator. We are having a piston here. Also, you can see from this um, line diagram also. Okay, the piston is continuously doing up and down to motion. Okay. See, let's make the RPM here. Let's discuss the beam engine first. Okay. Make the RPM 0 here. Okay. Remove this stress here. The crank, what is the crank here? Okay, make it okay. Now here see this blue one. This blue one is the crank length. Okay, currently it is at 87. You can decrease or increase the length also. See, the blue one length is increasing. Okay, so you can also find here a logged change. Okay, now it is showing because it is not following the this Hoff's expression, which was what? Which was S plus L. What is the length of the shortest and the length of the longest length should not be greater than, okay, some of the other two links P plus Q. So here was S, here was L. Yes, should not be greater than the length of these two than other two P and Q. Okay. If there is to be continuous relative motion between the two. Okay. If this expression is not following, then we will be getting a locked chain. Okay, so these expressions must be followed. Okay, means Grashof laws should be followed, otherwise the mechanism will not work. Okay, this was for the 4 bar crank chain in case of the beam engine. Now let's decrease it or make fit into the Grashof. Let's follow the now the we have appearing the 4 bar chain. Okay, so likewise you can increase or decrease the length of the crank here, the blue one. Okay, coupler similarly you can, okay, see the green one, link 3 is our coupler. Okay, you can increase or decrease the length also. Similarly lever, this uh, yellow line is the blue one, currently at 159, okay, length. So you can accordingly decrease and increase the length also. RPM currently is 0, so make it a, okay, now it is, let's increase the RPM length. Now it is rotating. Okay, now you can increase the speed also. Okay, like this. Okay, now make it here 0.5 x speed. Now trace. Okay, how when the mechanism is rotating, what is the output of the mechanism? Output means how the construction of the curve this mechanism is making. So see here, C is what? C is the point where the actual motion, construction, geometry, motion of the mechanism is we are getting. See, C point is making a curve. Okay, so just play with the crank length. Okay, now in between you will find that there the chain is getting locked. What does it means? Once again, it is not following the grass of lock. Okay, see locked chain. Okay, so you will have to set crank, coupler and length in such a way that you must not get a locked chain. Okay, the grass hop must be followed. Okay, like this. So make it. Let's say I'm making it 30. Okay, 33, and then after make it set this at 20, well, 207, and this lever I'm setting at, this lever I'm setting at is setting as 207 or 208, and this I'm setting at like this. Again it is not following, so you must have to play with crank, coupler and length in such a way that it must follow the expression. Okay, then only you will be able to will increase the rpm. Again it is not. Okay, see the lever I am increasing the length. Okay, just all locked and chain has been locked. Okay, completely locked. Now it's working fine. Okay, see here, see how it is working. Okay, now it's so you have to play with the crank, coupler and length so that the chain of the kinetic chain must not be locked. Okay, this was for the beam injet crank. Okay, you can. Okay, this is how the red one is showing that the construction line making by the mechanism. Okay, now let's see the other one, coupler. Okay, rpm we are setting. So what we had seen was after beam engine, coupler, coupling rod. Okay, we are having a two cranks, lever 4 and lever 4. Link 2 was the double crank. Okay, similarly here you see here. Okay, the blue one. Okay, this one and this one is our what, crank. Okay, you can increase the length also. Okay, so you can increase the length of the blue line, means crank length. Okay, rod length. Okay, ignore that. Wheel radius, see the radius of each wheel you are increasing or decreasing. Okay, okay, now let's play this. See how the coupling rod is rotating. Now make it, put it here, trace. Okay, make the speed slow here, very slow. See here, this midpoint of the green one, PC link, okay, is making a curve something like, constructing a curve something like. Okay, so the output of the curve of this mechanism we are getting is this error. Okay, so you can just increase the wheel radius. See, I have set at 143 sail in unit length, and the crank I am just decreasing. How the make the RPM little higher. See how the construction line is we are getting. Okay, make the crank length little higher. Length. See, construction line we are getting with larger diameter. Okay, and further large. Okay, so by this way you can get the coupling rod. Okay, now the third one and the last one is our what, the watts indicator. This we had seen in the lecture. Okay, this piston is coming to, continuously doing the up and down. Okay, see here, make the amplitude means the piston is moving to and fro, up and down. Okay. What is this? Lever. The blue one, this blue one is showing the lever length. Okay, so you can adjust the lever length. Okay, whatever the length. Okay, coupler is what? Coupler one is the green one length. Okay, output lever is what? This yellow length. Okay, okay. Amplitude is that how fast the piston is moving up and down motion. Okay, so just see how the piston is doing the up and down. Make it little smaller. See, you can notice that how it is moving up and down motion. Okay, see, you can notice it doing the up and down motion. Okay, so by this way you can obtain the watts indicator. Okay, mechanism. Okay, how it moves. So that's all about the inversion of 4 bar chain. Okay, so you have to keep in mind that only the three cases we are having in 4 bar chain: beam engine, also known as crank and lever mechanism. Okay, the second one is the coupling rod, also known as a double crank, because we are having two blue lines, crank line, uh, two links. Okay, and also known as double crank. Here we are having a two levers. Okay, lever is input lever is this one, input lever is this blue one, and the output lever is our what, yellow one. Okay, so this is how the, okay, we are getting the output from the mechanism. Okay, so that's all for the case of the inversion of 4 bar. Thank you all.